Hey guys, how you doing? This is Coach Scott. Let's do our third video in our series on chemical reaction. We're going to be talking about balancing reactions today. So anyway, and we'll be doing a lot of this in class. Hopefully you guys did this in 8th or 9th grade and you've mastered it and you feel really good about it, and this will be easy. All right, and I'll give you some tricks of the trade on how to balance. So to write a balanced chemical equation, first we write the skeleton equation. Then we're going to use coefficients, the number in front of the formula, to balance the equation so we obey the law of conservation of mass. Now, this is a balanced equation for making a bicycle. The numbers are called coefficients. All right? The small whole numbers that are placed in front of the formulas in the equation in order to balance it. So that's our product, a bicycle. We have one frame, two wheels, one handlebar, and two pedals. So we take these two pedals, the frame, the two wheels, the handlebars, and we have a bicycle. So that would be the formula for a bicycle. So to balance the chemical equation, we write our skeleton equations. Reactants, remember, are on the left side of the equation. All right. Products appear on the right side of the equations. And then we'll write the state of the reactants and the products in parentheses to the right of the compound. So CH4 has one carbon, four hydrogens. Oxygen has two oxygens from the skeleton equation. CO2 has one carbon and two oxygens. Water has two hydrogens and one oxygen. So we use coefficients to balance out the equation. All right, so we're missing two oxygens here. All right, they've got four oxygens on this side, so we're going to put a 2 there. So we have four oxygens on this side. We have one carbon on this side, one carbon on this side. We're getting the law of conservation of mass. We have four hydrogens on this side. Originally we only had 2. I put a 2 there. That means I have four hydrogens. Remember, 2? And that gives us a balanced equation. We have the same number of particles on the left as on the right. So the subscripts indicate the number of atoms of each element in a molecule. If we change the subscripts, that's going to change what the material is. You can't do that. Coefficients tells us the number of the representative particles, either atoms or molecules or formula units. Now we can change the coefficients because all that's going to do is change the amount of a compound or a molecule in the equation. So this is what we want to consider when we balance something, right? So here we've got two hydrogens on the reactant side. We've got two chlorines on the left-hand side or the reactant side. See, we put it up here on the table, and this is how I do it. I just take each one of those and separate them. Then I'll draw a line, and on the right-hand side, I'll write what we have. We have one hydrogen and one chlorine. So instead of 2, we've only got 1. Instead of 2, we've got 1. So I'm going to throw a coefficient on the right-hand side, the product side. I put a 2 in front of the HCl. Now we're balanced. I have two hydrogens on this side, two hydrogens on this side, two chlorines on this side, two chlorines on this side. I am meeting the law of conservation of mass. I have balanced the equation. So let's talk about this. We're going to write a balanced equation for this reaction. Chlorine will react with sodium bromide and to produce bromine and sodium chloride. So we're going to write a skeleton equation. Chlorine, have no fear of ice cold beer, the C, that's going to be diatomic, it's going to be Cl2. And sodium bromide. All right, so that's a ionic equation, right? So sodium's +1, bromine's -1, is NaBr. Bromine, that's one of those diatomics, so it's going to be a Br2. NaCl, that's also ionic, plus 1 minus 1 NaCl. So now I have my skeleton equation. So I'm going to write my equation out, draw a line. I like to put that line right there where the arrow is. Then I'll write each of my elements on each side. So I have chlorine, sodium, and bromine. I've got chlorine, sodium, and bromine on the right-hand side. So from the equation, I see that I have 2 chlorines on the reactant side. I have 1 sodium, and I have 1 bromine. I write those down. Then I look at my product side. I have 1 chlorine on that side, 1 sodium, and 2 bromines. I'm going to have to do something. I'm going to have to put a coefficient somewhere to balance those out. So let's work at chlorine first. I've got 2 on this side, 1 on that side. If I put a 2 there, all right, that would give me 2 chlorines. It would also give me 2 sodiums. All right, so let's put a 2 there. All right. So we need more on the product side. Okay. So that's the only one that contains chlorine, which is moving quick. I put a 2 there. Okay, I need 2. I have 1. I divide that. The need by the have, I get 2. So I put a 2 there. That'll give me 2 chlorines. It also means I have 2 sodiums. Now let's see what we've got. 1, 2, 1, 2. I've got 2 there, 2 there. Ooh, I got 1 and 2. So now we need to work on the reactant side. All right, and if I see that I need 2, I have 1. 2 divided by 1 is 2. I put a 2 there. That gives me 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines. Now I've got 2 bromines. 2 bromines. That is now a balanced reaction. So again, we're going to be doing a lot of these, right? A lot of these in class, in practice, to where we can balance the reactions. And I'm going to be talking about some more little tricks and tips of the trade so we can be very successful at balancing chemical equations. Okay, guys, this is Coach Scott saying y'all have a good day, and coming up on spring break pretty quick. See you guys. Love you. Bye.